Hello class, I hope you're having a wonderful day. Today I would like to complete another problem from chapter 6, Motion in Two Dimensions. So what I'm going to do is read the problem and I'm going to underline some important information. We're going to generate a column of knowns and unknowns, draw a picture, and then we're going to go step by step solving the problem. So let's go ahead and get started. An airplane is flying 1,001 meters above the ocean at 125 kilometers per hour. And it's going to drop a box of supplies to shipwreck victims below. So in part A, how many seconds before the plane is directly overhead should the box be dropped? So we're looking at time interval right here. And then in part B, what is the horizontal distance between the plane and the victims when the box is dropped? So we're looking at displacement of the box in the x direction. So what let's go ahead and do is generate a column of knowns and unknowns and draw a picture. So we are 1,001 meters above the ocean. So when we drop the box, it's going to have a displacement in the negative y direction. So negative 1,001 meters. So d sub f sub y, negative 1,001 meters. And our velocity in the x direction is 125 kilometers per hour. Now we know that we are going to need to convert our velocity from units of kilometers per hour to units of meters per second. And we're going to do that by using dimensional analysis. So we're going to treat our units as algebraic quantities so we can cancel them. So let's start with our time unit here, hours. So in 1 hour, we have 3,600 seconds. So we know units of hours will cancel. And then in our numerator here, we have units of kilometers. We know we need to convert that to units of meters. So in 1 kilometer, we know that there's 1,000 meters. So let's go ahead and cancel our units of kilometers. Let's take out our calculator, and we have 125 divided by 3,600, and then times 1,000. This gives us 34.72 meters per second. Okay? Yeah. All right. The next thing we need to do is draw a picture. Okay, so if we have an airplane here and it's flying with the box and we're dropping it on a target here. Let's say this is our target. So our height that we're dropping it from is 1,001 meters. And it wants to know what the displacement in the x direction will be. So d sub f sub x right here. Okay, so for part A, how many seconds before the plane is directly overhead should the box be dropped? So step number 1 is going to be for us to calculate the velocity in the y direction. So step 1 is going to be calculate the final velocity in the y direction. And then step number 2 is going to be for us to calculate delta t. And I'm going to use the subscript of ht to hit the target. Okay? So step 1 right here, we're going to use the base equation. Final velocity squared is equal to initial velocity squared plus 2 times the acceleration times the final displacement of our object. So we need to adapt this equation to our situation here. So we have final velocity in the y direction squared is equal to initial velocity in the y direction squared plus 2 times the acceleration in the y direction. Now we know that the box, once it's dropped, is going to accelerate in a negative y direction, negative 9.8 meters per second squared. So the acceleration due to gravity. So negative 9.8 meters per second squared. And our displacement in the y direction is negative 1,001 meters. Okay? Now the easy thing about this situation is our initial velocity in the y direction is 0, and we know that 0 squared is still going to be 0. So what we have here is final velocity in the y direction squared is going to be 2 times negative 9.8, that's negative 19.6 times negative 1,001. This gives me 19,619. Now let's take a look at the units. Right here I have meters per second squared multiplied by units of meters. And algebraically we can write this as meters over 1. So this is going to give us meters times meters. This is meters squared. Second squared times 1. This is second squared. Now we're not done, because on the left side of our equal sign we have a square. In our exponent, we need to get rid of that by taking the square root. And you know that taking the square root of a squared value, those are canceled. But what you do to one side of the equal sign, you have to do to the other side. So we're going to square root the right side as well. And this is going to give me a final velocity in the y direction of 140 meters per second. So we're taking the square root of the numerical value and the square root of the unit value. So 140 meters per second. Now remember, this is velocity, so we're required to show direction. And we can write down or negative y direction, or show a vector arrow in the negative y direction, or we can simply place a negative sign to show direction, okay? And that's what I'm going to do. All right, so we're going to need this value to calculate the time it takes for the box to hit the target, okay? So the base equation we're going to use to solve for that is the acceleration of an object is equal to the final velocity of the object minus the initial velocity of the object divided by the time interval. Now, applying this equation to our situation, we know that we're looking at the y direction, and the acceleration in the y direction is the acceleration due to gravity, identified by lowercase g. This is equal to the final velocity in the y direction minus the initial velocity in the y direction divided by the time, and I'm using a subscript of ht to hit the target. So we need to isolate this right here, and we're going to do that by multiplying both sides of the equal sign by delta t sub ht, and then dividing by the acceleration due to gravity. Okay, so what we have here is delta t to hit the target is equal to the final velocity in the y direction minus the initial velocity in the y direction divided by the acceleration due to gravity. So we have final velocity in the y direction. We're going to use our calculated value here, negative 140 meters per second, minus our initial velocity in the y direction, you know, is 0. I'll go ahead and write that down for clarity there, 0 meters per second, divided by negative 9.8 meters per second squared. And this gives us 14.3 seconds. So delta t to hit the ground, I'll go ahead and write the answer over here. 14.3 seconds. I'm also going to erase this over here, so I'm going to copy down the final velocity in the y direction as well. And and that is negative 140 meters per second. And we're obviously ignoring aerodynamic drag here. Okay, so part A, how many seconds before the plane is directly overhead should the box be dropped? 14.3 seconds. Okay? In part B, it says, what is the horizontal distance between the plane and the victims when the box is dropped? So what we're going to do is use the base equation. Distance equals our average velocity multiplied by our time. So we're going to use this equation, we're going to adapt it to our situation, and our displacement is in the x direction. So the final displacement in the x direction is equal to the velocity in the x direction multiplied by the time to hit the target. Okay? So what we have is velocity in the x direction, and you've already calculated that. We used dimensional analysis here. 34.72 meters per second times the time to hit the target. We're going to use your calculated value here, 14.3 seconds. Right here, units of seconds, we can see that that will cancel out. And we get final displacement in the x direction is equal to 496 meters. Okay? So I hope this video has helped you solve the problem. If you have any questions, please give me a call or send me a message, and I will be more than happy to help you. I hope you have a wonderful day.